Right, first we want to talk about the motion of a charge which enters the electric field perpendicularly. Example, so let's say I have two parallel plates here. And let's say this is positive and this is negative. So the field will be vertically downwards, right? Now let's say you project an electron horizontally into the field. So you project it horizontally into the field with speed v. So it will experience an electric force. Agreed? So which direction will the electric force be? So once it enters the field, the electric force on an electron will be opposite to the direction of the field. So that means the field is downwards, the force has to be upwards. Well done, Park Yun Lee. Right, so when the force is upwards, so that means it will curve upwards. Correct? But some people ask me, what about weight? Does it still have a weight or not? So it does have a weight. Okay, but the weight is negligible compared to the electric force. Do you understand that? Because we're not talking about a large particle, we're talking about a charge like an electron. So the weight is negligible compared to the electric force. So we don't have to consider the effect of weight. Understand? Alright. So it will move in a curve upwards. Now why? Because it will undergo a projectile motion. And in all projectile motion, it will follow this rule. One direction will be constant velocity. 90 degrees to it will be constant acceleration. Then you will get projectile motion. Example, when you learned in kinematics, motion under gravity, just to recap, if you project a ball at a velocity v at an angle theta, it will undergo a curve. Why? Because if you break down the velocity to two components, you have v cos theta and v sin theta. Now, because the weight is acting downwards, that means the acceleration is also downwards, right now? And horizontally, there are no forces acting because you're ignoring air resistance. Therefore, there is no acceleration horizontally. That's why horizontally, you will get constant velocity. And vertically, downwards, you get constant acceleration due to gravity. Which is why you will undergo a curve. Because every time you're trying to go tangent to the curve, that means you are always trying to move tangent to the curve, the weight keeps pushing you down. That's why you keep curving. Do you understand? So projectile motion is a result of constant velocity and constant acceleration perpendicular to each other. Understand? So in this case of an electric field, it's the same case as well. Because when the charge is moving in the field, no matter where it is, so let's just trace the curve here. Let's say it goes through this curve. Let's say it is at this point here, the electron. Do you still agree that the electric force is still vertically upwards? Correct or not? And if it's vertically upwards, that means acceleration is still vertically upwards. Now, is the force constant? Yes, because it's a uniform field. So F equals to EQ. Field strength is constant, force is constant. So therefore, your acceleration from F equals to ma, the A must also be a constant. So you have a constant acceleration vertically upwards. Do you understand that? At the same time, you also have constant velocity horizontally. So can you see 90 degrees to each other? So you get projectile motion. So for projectile motion, how do we solve? So when you want to solve, you need to solve separately. That means horizontally and vertically, you need to solve separately. So in this case, horizontal is constant velocity or constant acceleration? Constant velocity, because the only force is electric force upwards. Do you understand that? So horizontal, no force. So it's constant velocity. So constant velocity, there's only one equation you can use. You cannot use any of the kinematics equations because kinematics equations are for constant acceleration. Well done. So constant velocity, the equation is distance equals to speed multiplied by time. So the distance, horizontal distance, let's call it x here. Your speed, let's say, is v, so it's just v times t. That's the only equation. No other equations, that's it. But vertically, since your force is upwards, so let's take vertically upwards as positive. Okay, so that's our sign convention. And this will give you constant acceleration. This will give you constant acceleration. And constant acceleration, what equation can we use? Any of the kinematics equations. So, let's say we want to use V equals to U plus AT. Now, if you project the electron horizontally, does it have an initial vertical speed? Because you are entering horizontally, so will you have any vertical speed? No. So initial vertical speed will be 0. So the vertical speed Vy will be equals to the acceleration times time. That's it. Understand? Now, if you use, let's say, another equation, S equals to ut plus half at squared, same thing, the u is 0. So the vertical displacement y will be just half a t squared. And you can repeat it for the other equations. Okay, for example, let's say you want to use v squared equals to u squared plus 2as. So this will be vy squared equals to 0 plus 2ay. Now the only thing you have to be careful about is in the value of your acceleration. If it is motion under gravity, your acceleration is just 9.81. You don't even have to calculate it. But because this is motion in an electric field, you must calculate the acceleration. You cannot use 9.81. So how do you calculate the acceleration? Remember from the formula F equals to ma, we can find the acceleration because the force is electric force, which is EQ. So from this equation, we will be able to find the acceleration. And it's this value of acceleration that you must substitute in each of these formulas. You understand? So that is how you solve projectile motion. Now sometimes the field can be horizontal rather than vertical. Example, if your plates are vertical and this is positive, negative, then the field will be horizontal, right now. So if let's say an electron enters into the field vertically, then the force it experiences will be to the left. Correct or not? So therefore, the force will be horizontal. So in your case, vertically will be constant velocity. That means you need to use distance equals to speed times time. But horizontally is where you have constant acceleration. So then you can use any of the kinematics equations. Understand that? So you don't blindly memorize. You see, if it's motion under gravity, then for sure vertically is constant acceleration. But if it is electric field, then it could be either vertical is constant acceleration or horizontal is constant acceleration. It depends on the direction of the electric field. Understand? Because gravitational field is always vertically downwards. There's no other variation. But electric field can vary. Okay?